you imagine a planet way out there with huge oceans, a crazy protective atmosphere, and it's not just good for life, it might be better than Earth. And guess what? The James Webb Space Telescope, the most insane telescope ever, is looking at these planets right now. What if one of them is sending us some wild signals? This is nuts. For thousands of years, people have stared at the stars asking, are we alone? Finding another Earth, a real Earth 2.0, isn't just for movies anymore. It's a real mission. We're talking about a planet that's not just alive, but maybe even a safer, richer, longer-lasting home. So what's this paradise planet even look like? Scientists think it could be a super Earth, bigger than our planet, with stronger gravity for a thicker atmosphere. Imagine massive oceans crawling with life. It might orbit a super chill star, giving it billions of stable years. It needs a magnetic shield and those cool moving plates like Earth for nutrients. Basically Earth, but on steroids. And with the James Webb Telescope, this isn't a dream, it's happening. This telescope can see atmospheres on other planets. This is a game changer. Before this mega telescope, finding out what alien atmospheres were made of was almost impossible. We could find planets, sure, guess their size, see if they were in the Goldilocks zone. You know, where water could be liquid. But what was in their air? Total guesswork. JWST, it flips the script. It uses this super smart trick called transit spectroscopy. When an exoplanet zips in front of its star, the telescope watches starlight filter through its atmosphere. Different molecules in that air grab specific light colors, leaving a unique chemical fingerprint. Using these, scientists can spot gases like water vapor, methane, carbon dioxide, and, get this, potential biosignatures, gases that could scream life. JWST is so sensitive it can pick up even tiny whiffs of these gases, giving us our best shot ever at finding planets with aliens. It's like sniffing a planet's air from light years away. How crazy is that? So one of the craziest planets JWST is checking out is K2-18b. It's 124 light years away? That's far. This thing is a monster, around 8.6 times Earth's mass and 2.6 times wider. It's orbiting a red dwarf star right in its habitable zone, meaning temperatures there could allow for liquid water. Even before JWST, early peaks hinted K2-18b might be a Hushin world. That's a pretty new science idea for a planet covered in gigantic liquid water oceans under a hydrogen-rich sky. These Hushin worlds could be habitable in way more places than Earth-like planets, maybe making them super common spots for life in the galaxy. And boom! JWST's earlier look at K2-18b back in 2023 made huge waves when it found carbon-based molecules, including methane and carbon dioxide, in its atmosphere. This was insane, the first time these kinds of molecules were found in the atmosphere of a habitable zone exoplanet, and it totally fit the Hushin world theory. Now this is where things got wild and super confusing for scientists. Around K2-18b, we're talking late 2023 and into 2025, reports about a molecule called dimethyl sulfide, or DMS. Here on Earth, DMS is almost entirely made by living things, especially tiny ocean life. So finding it on an exoplanet, that could be a massive clue for actual aliens. Some early looks at the JWST data hinted that DMS, and maybe another related molecule, might be in K2-18b's air. These first super tentative findings came from a team at Cambridge University, and, you can guess, it sparked a firestorm of excitement. Some headlines even blasted things like a 99.7% chance of life, based on something called a 3 sigma statistical result. A 3 sigma result means there's a 0.3% chance the signal was just random noise. Pretty interesting, but not a slam dunk. For scientists to really go nuts over discovery like this, they usually want a 5 sigma result, where the chance of it being a mistake is tiny, like 1 in 3.5 million. But, and this is really, really important, science is all about checking and rechecking everything. Those first hints about DMS, they were and still are totally up in the air. As of June 2025, there's no confirmed, scientifically approved detection of DMS on K2-18b. The early hype hasn't been backed up by other independent studies or official NASA or ESA announcements, period. In fact, a bunch of other science teams looked at the exact same JWST data and didn't find strong enough proof for DMS on K2-18b. Some studies think other molecules, or maybe even weird stuff happening in the atmosphere we don't know about, could explain the faint signals that were first thought to be DMS. One analysis even said, hey, if you look at a ton of possible molecules, it could just be other non-living stuff like propine. The scientists who made those first Cambridge findings have themselves told everyone to chill out, saying way more observations and a lot more testing are needed. Professor Niku Madhusudan, who led the Cambridge studies, has been super clear. They're not claiming they've found life, but are just exploring the possibility. Also, the amount of DMS they initially thought might be on K218b was thousands of times higher than what we see on Earth. That makes you wonder what could produce so much of it: life or something else totally bizarre. So while the idea of DMS on a Haitian world is super exciting because it's a known sign of life on our planet, the current scientific agreement is that the evidence for it on K218b just isn't there yet. This doesn't mean K218b isn't still an awesome place. It just means that specific claim about DMS hasn't worked out so far, and maybe never will. Science is working exactly like it should. An exciting hint gets totally ripped apart, debated and tested by everyone. This whole idea of a paradise planet, or one that's better than Earth, is pretty wild. But what would it actually mean? For humans to actually live there, an ideal exoplanet would need some key things. The perfect spot. It'd have to be orbiting in the habitable zone of its star, so liquid water could actually exist on its surface. No water, no paradise for us. Awesome atmosphere. A stable atmosphere with the good stuff like oxygen, though oxygen itself is a huge biosignature that would need insane checking. Nitrogen, some carbon dioxide to keep it warm, and water vapor. Plus, it would need a shield from nasty star radiation. Comfy conditions. Temperatures, pressures, and gravity that we could actually handle. A planet way bigger than Earth might have crushing gravity. For instance, K218b is much more massive than Earth and has that thick, hydrogen-rich atmosphere. Even if it has an ocean, the surface pressures and temperatures would likely be way too extreme for humans. Its atmosphere is totally different from Earth's nitrogen-oxygen party mix. A chill star. It should orbit a star that isn't always blasting out violent flares that could strip away its atmosphere or fry the surface with radiation. Red dwarf stars like the one K218b orbits are famous for this kind of drama, which is a big worry for long-term habitability. And how could a planet be better than Earth? More stability. Maybe a planet with more stable plate tectonics, meaning fewer giant earthquakes or volcanic mega-disasters. A perfect climate. A world with a naturally steady global temperature, without insane ice ages or extreme heat waves burning everything up. More land or resources, though what life needs can change a lot. A longer life. Orbiting a star that will stay stable for billions of years longer than our sun. Imagine that. It's really important to remember that no exoplanet found so far, K218b included, has been proven to be a better home for humans than Earth. For now, our planet is the only paradise we know that's perfectly set up for us. The idea of finding a better Earth is still in the realm of exciting future possibilities, not something we've already found in our backyard. The James Webb Space Telescope is really just getting started. It's going to keep observing K218b and tons of other exoplanets, collecting more data and helping us get a clearer picture of their atmospheres. Every observation adds another piece to the puzzle. Confirming biosignatures is a slow, careful process. You have to rule out every single non-biological explanation. This is definitely a marathon, not a sprint, people. Scientists are always coming up with smarter models to understand the data JWST sends back. They're also thinking about a wider range of potential biosignatures, not just the ones we see on Earth, because life somewhere else could have a completely different chemistry. Mind-blowing. Those early unconfirmed hints of DMS on K218b, even though they haven't held up so far, have still been useful. They've kicked off a lot of research, shown off JWST's incredible abilities, and really drilled home how careful we need to be when we're talking about potential signs of alien life. The scientific community is actively discussing these findings, which is exactly what good science looks like. Everyone arguing and figuring it out. Future telescopes and missions will take what JWST has started and run with it, giving us even more powerful tools to scan the skies. We're moving into an age where we might go from just listing exoplanets to truly understanding what they're like and whether they could support life. So while K218b might not be the confirmed Earth 2.0 with definite signs of alien life that some early headlines hinted at, it's still an amazing natural laboratory. It's a Haitian world candidate in the habitable zone, and JWST has confirmed methane and carbon dioxide in its atmosphere. And those are big deals on their own. The mission to understand worlds like this continues, And every new piece of information, even if it dials back some of the initial crazy excitement, gets us a little closer to figuring out our place in the universe. The James Webb Space Telescope has thrown open an incredible new window on the universe, letting us examine the atmospheres of worlds light years away in stunning detail. Planets like K218b give us exciting little glimpses into the sheer variety of worlds out there beyond our solar system. While the dream of a confirmed paradise planet with undeniable signs of alien life is still just that, a dream for now, the scientific journey to check out these possibilities is more active and thrilling than ever before. Those early, heavily debated hints of molecules like DMS on K218b show us just how challenging this search is and how crucial it is to be cautious. But they also shine a huge light on the amazing potential of our new tools. This search isn't just about finding another Earth. It's about understanding what makes a planet habitable, the potential for life in all its different forms, and ultimately, our own story in the cosmos. The universe is a huge place, and we're only just starting to uncover its secrets. What do you think? Does K218b still hold promise as a potentially habitable world, even without confirmed DMS? What kind of planet pops into your head when you imagine an Earth 2.0? I'd love to hear your thoughts in the comments below. If we've just satisfied your curiosity, give this video a thumbs up and share it with someone who's just as curious. And if you're hungry for more quick, thought-provoking answers, click on these next videos and stay a brief ahead with Why in Brief. Thanks for watching.